code. And then from there, what typically in the AppSec industry we tend to do with SCA is tell you what licenses you have, what vulnerabilities you have. You can then generate a bill of materials, for example. So we're just going to discuss that, talk about the techniques that you can use. We're going to touch on a little bit like free tools and paid tools, and then we're going to look at how Mend basically kind of secures you against like vulnerable techniques. And then we're also going to touch on SAST as well at the same time, which is another pillar of application security. SAST is a static analysis of your software. And then in this particular sector, what we do is we tell you about weaknesses in your source code. So if you have a SQL injection, for example, and you have a web-facing application, that's a recipe for disaster. So we're going to show you basically the value points, how you can stop the introduction of anything new. So that's kind of the methodology of stopping the bleed. And then we're going to look at the different techniques that we can use. So if I can begin, again, just a bit of a background on myself. I've been with Mend for nearly 2 years now. I work for a wider range of companies, like startups, like Arrival, you might have heard of. At the time, we worked on infrastructure there. So that's kind of a very, very broad set of requirements. But when you work for a startup, the challenges are different when you work as opposed to when you work for a local government. With local government, things are very lean. You have less people there. The challenges are very different, and also the opposition. So the people who are kind of threatening your IT infrastructure, they're very different as well. So there's different challenges. So today's topic is going to be broken down generally into 5 areas. So what I'm going to do is going to quickly discuss these topics, about 10 minutes, and then we're going to go into GitHub and show you kind of feature sets and how that practically can look like for your developers. So one of the topics will be SBOM, commonly referred to as a software bill of materials. In the US, it's mandatory now that you have a software bill of materials if you have software and you're packaging it for distribution. So we're going to look at the introduction of an SBOM to the IT sector. A bill of materials has been common for years. If you make anything, let's say a car, a tin can even, for example, you know exactly what's been put in there, where it's come from, its provenance, for example, and that's what it is for software. We're going to look at open source. The big kind of term around open source is shifting left, and we're going to look at how that basically, typically that focuses on vulnerabilities, whereas where the true AppSec or DevSecOps can come from is actually managing the dependencies. So that's updating your dependencies to the latest version, because in essence, it's the same amount of work, patching something or actually fixing it in totality. So we're going to look at that as well. We're going to look at open source licensing as well. There's been a few stories recently about people who didn't know they had particular kinds of open source licensing in their software. They've fallen foul of it and they've had to pay a big sum to the owners of that open source software. So again, very briefly, just because it's open source doesn't always necessarily mean it's free of cost. We're going to look at getting started as well. There are some good free tools out there that might get you kind of 5% of the way there, but in a large fintech organization, it's just not going to scale. So we're going to look at the free tools versus what the paid enterprise tools tend to give you, which is a common track in terms of people coming to Meteonic, coming to Mend and saying, hey, we have a few free tools, but they're all separated. We need an enterprise solution that can be managed and scaled. And it's going to, as a segue, it's going to lead us on to our demonstration, scanning the repository, the different points of scanning at the repository, managing all of the risk that sits in there, licensing, infrastructure as code. We're going to basically discuss how it's the actual true DevSecOps or shift left is actually managing the repository. So SBOM, I've kind of lightly touched on it. An SBOM can be a receipt, if you like, or you go to a shop, you get a receipt about what you've purchased, and an SBOM is exactly that. It's a bill of materials to tell you that this bit of software that you're shipping or you're using internally or you're consuming from someone, this is what's in there. These are the licenses. This is its source. This is its author. It wasn't that popular maybe 10 years ago, but there's been an executive order in the United States, and as generally what tends to happen in any industry is the United States has an order on it, it becomes popular there, and it spreads. As a result of the executive order, we're seeing the European Union also release DORA, which has a section which is eerily similar to the executive order, which basically means that if you're selling software, you need to have a bill of materials, a provenance of what's in there. So what we're now seeing is European entities come to us and say, okay, we need this, we need a solution that can accurately map what open source licensing we have and basically give us this this receipt, this report of what we have in there. So as time goes on, that's exactly what we want. SBOB can also tell you about transitive dependencies you have as well. So it's not just the 10 open source libraries you're pulling in. They normally have other downstream dependencies which make them work, right? And they can have things like different licenses, for example. They can also have vulnerabilities as well, for example. So again, it's just about knowing about the risk and then actively managing that risk as well. And that's what a bill of materials does for you. As I mentioned, a bill of materials, it's standard in other industries. Like a vehicle, for example, if you wanted a part, let's say a headlight has an OEM part number. It also has an OE part number. So the original manufacturer has a part number for that. And you've all seen the diagrams where things are kind of exploded, and you can see this is part A, this is part B. Everything has a number. It's the same for software, and that's where everything's going. And it makes sense, right? You wouldn't build a piece of software and say, "Yep, it's safe. Here you go." You need some sort of provenance, and as the insurance, that's what something like an SCA tool like Mend can do for you. So we can see if we're looking at maybe managing the dependencies versus managing the vulnerabilities themselves, that's kind of the two pillars of how an SCA solution can work. Managing the vulnerability essentially means updating out of a particular library. Let's go to the least vulnerable version. Alternatively, let's accept the risk. That's also a part of managing the vulnerability. That doesn't really tend to get you anywhere because you're now in a perpetual state of, okay, I need to update. There's a 0 day, there's another 0 day, there's another 0 day. So you're almost always being reactive rather than proactive. What managing the dependencies does is, first of all, Mend can actually automate the degeneration of that update. So you're actually managing it less than you would be managing a vulnerability, for example. And what we're doing is we're telling you, hey, here are the new versions that you can go to. These are minor updates, so they're non-breaking changes, give you contextual information, and we can actually say, we're managing all this for you. Just go to the latest version. And you can see it here, around 90% of 0-day vulnerabilities, they're patched before they're publicly disclosed. So more often than not, all a 0-day event is, you're making sure that you're not on that version. And 90% of the time, you're not going to be because you're actually managing the life cycle of that dependency. I don't need to explain too much about how much time that's going to save you, especially if it's automated. All you need to do is make the checks yourself and say, okay, here's the latest version that I can go to. And what you can also do is check that that version isn't vulnerable as well. So again, you're not kind of falling into another vulnerability. Mend's solution to that is what's called Renovate. So Renovate, as the name might suggest, is that you are actively looking after those dependencies. And what we're able to do is, because there is also kind of a free solution of that out there, is we're able to tell you what particular version that you go to in terms of what age that version is, its adoption rating, if it passes any test, and we can give you what's ultimately a confidence rating. So we can give you a confidence rating of high, very high, neutral, low, and it basically gives you, the developer or the organization, for example, the power to know that that's a good version for you to go to.
Nick, can we have quick poll thing? What we have, so we know, like, where we can focus. Kakash, can we run the first poll? So we have prepared a set of questions which will help us to focus on the type of audience we have. Kakash, can you run a poll, please? Yeah. So among the following functionality related to application security, select your top 3 cases which you will be interested to learn about. So you guys have, yeah, sometime, yeah, good. Thanks for all your responses. We are getting vulnerability scanning and identification, remediation strategy and best practices is also a lot of people are clicking. Integration of security tools into development pipeline, excellent. Threat modeling and risk assessment, compliances is also something which a lot of our participants want to do it. So last 5 seconds, if you guys can do it, excellent. So Akash, you can end the poll and the display, share the results. 60% of you shows vulnerability scanning as a number one thing, remediation strategy as a best practices, and definitely integration of security tool into the development pipeline. Great, thanks for your input. I think now we know what problem you are having, so we can focus like that. Nick, go ahead.
Cool. So what we'll do in the demonstration in GitHub is we'll focus on those top 3 areas and we'll highlight them. So very briefly, open source licensing is just as big a part of open source as it comes to like vulnerabilities. For example, if you're using a bad open source license, you might, for example, only be able to use that particular open source library on a feature branch. And it's important that you know that, because if you're not paying the owner of that and you're utilizing it under that particular license, you'll then need to pay a sum to the owner or the maintainer of that particular open source license. These are typically known as risky licenses, and what we can do is we can basically highlight the use of risky licenses for you. So it's an area that essentially it's growing, because in terms of real-time costs, it's much more prevalent. So if we look at scanning the repository, your question could be why? Why would you scan the repository? Now you can scan on, let's say, ad hoc on your machine on a command prompt. You can scan in your IDE as well. The problem is what you scan on your machine might not be what you scan in your IDE, and it's definitely not going to be what's in your repository. And that's because we consider the repository to be ultimately the source of truth, right? That's where everything is consistent with what's being put out. There's no technical drift, if you like, from that point of view. And that's why it's powerful to check in a repository level. So you can check on other branches. You can check your pull requests into your default branch. You can check the default branch itself as well. And you can raise issues. You can have PRs be automatically raised to fix things or to patch things to a later level, for example. That's why scanning in the repository is really where everything comes together, and it's really where you're going to get the most value from a solution like this. Now, I had QA in there, but does anyone have any questions, or are you happy for me just to go straight into the demonstration in GitHub for you?
Yeah, if you have a question, you guys can just raise a hand. I will give or put it in chat window.
Perfect.
Okay, I think we're doing good. Maybe we will do it later. Question and answer, Nick.
No problem. So I'm just going to share my screen again. Okay. So what we're looking at now, just as it loads, is a GitHub repository. And in here, I'm going to show you the different elements of how we can fix things, how we get alerted to vulnerabilities, and then I'm going to go into the MEND dashboard, and then I'm also going to show you how at a high level you're going to see the results be presented to you as well. The persona that would be in a repository in GitHub is different to one that would be in a security dashboard. Who would be in a repository, you might ask? That's more of a developer, for example, someone who's making active commits. It's their workspace. Someone who would be in a security dashboard typically would be a more senior security persona, someone who wants to pull off reports, create organizational policies, etc. So this is a repository that I've got in GitHub. What we've done is we've integrated MEND into it. MEND has an application here that enterprise customers can utilize, and we've onboarded this repository by way of a .white source file. This is a file that basically globally controls how the scanning is done and how it interfaces with GitHub itself. Now, if I was to make any kind of change here, we can see the checks that are done on every commit. So we do a code security check, which is a SAST check. So we're scanning to see if any new vulnerabilities have been introduced. We do a security check, which is a check for open source. So that's the SCA portion. And we also do a license check as well. So we define a policy for Mend to basically say there is a violation with this particular license. And that's what we're seeing in here. So the first kind of value point is that we're seeing these checks being done on these commits here as well. If I was to go back into my existing commits, for example, you'll see that some checks, they failed because I introduced either an infrastructure as code violation or I had vulnerabilities introduced. And if I go into here, you can see all the different CVEs that were found for this particular version of repository that I have here. So we have things like CVEs, we have MSCs, which are malicious packages. We have a WS as well. So very briefly, Mend has a threat and research team. Their full-time job is to find such threats and sort of attack surfaces. And when we find a threat, we give it a WS, which is short for Y source, we're formerly known as, and then we submit that to the NVD. If it gets a CV, we replace it. But ultimately, that's what the WS stands for here. What we can do at this level is we can open up these CVEs. We have more information about where it's been found. So the manifest in this particular example, whether it's a direct or a transitive vulnerability, these are all direct, as you can see, but this one's transitive. So the root library is promise, but ultimately it's PG 510, 510, that's the actual vulnerable version. And then the upgrades or the paths that don't have this particular CVE. Of course, you might not always want to upgrade, you might sometimes need to downgrade as well. What we can also do for actually managing these vulnerabilities is, you see here, we create issues as well. So within GitHub or within Jira as well, for example, we can create issues to actively manage these dependencies. You see here all the different kinds of issues that I have. Very briefly, the flavors of issues that I have are infrastructure as code violations, and these are recommendations to be made, so ensure the user for the container has been created. We have our code security findings, so these are our weaknesses. And we have our open source violations here as well. Now, I can just very briefly go into our code findings, and you see here that since the last commit, there are no new findings. There was nothing resolved either. We have total 11 project files that were tested. There's total 12 findings. I can go into here. I can see that this SQL injection, this particular file, there's 4 data flows for it. So that means that the input, there's 4 inputs, there's 4 flows that lead to the sink. And if I click onto it, I can view the individual data flows. And in the individual data flow, I can see the input, ultimately leading to the sink itself here. Now I can choose to go into products.js, and that will lead me directly to the file, and I can see that line there. So in terms of remediation, you can quickly work out what the problem is and how you can fix it as well. Now, code security findings are, of course, there's one finding here, also one issue here, and then there's many findings that sit within it. You can go down to see the findings overview as well. We also raise an issue per dependency as well. So you can see here all the different dependencies that have a vulnerability associated with them. I can go into body parser, for example. I can see the 2 CVEs that are created. You can see here, body parser to upgrade it to a different version. These are transit dependencies. Here's what's really key. We're showing you what version the root library is fixed in. Okay. Note that these 2 CVEs aren't actually with body parser, which is the root library. They're with QS. To fix anything in QS, we need to upgrade body parser. That's really key. And what we're doing here is we're essentially, you have a program that can actually tell you what version of body parser to upgrade, because that's the only way you're going to upgrade out of this particular vulnerability. What's key as well is we have a tab here for fix PR available. And that essentially means that Mend can raise a pull request to upgrade out of this version. Again, you and your developers, as having a program like this means that you don't actually have to go and find what version things are fixed in. That's all automated. And if I go to my pull requests, if I go to body parser, you can see The current version is 113. The recommended fix is 119. So it's a minor upgrade. And look at the options that we can give you. So in this program, your developer has 3 choices. One is to stay. One is to upgrade to the least vulnerable version. Alternatively, you can just go to the latest minor version. So I guess generally minor versions are not considered to be breaking fixes. So we give you the option to go to 122, should you wish to as well. I mentioned about information and metrics that you might have. And as a strategy, what a developer would do is, for example, look at this and say, okay, the recommended version that we tell you to go to, 119.2, its age is 1 year old. Its adoption rating isn't that good, ultimately. Its passing rating is quite high. So any tests that are done on these PRs or people who go to that version, it's a really high pass rating, ultimately gives you a really high confidence rating as well. So that could be a best practice to perhaps look at that and say, okay, it's a high or a very high. There isn't too much due diligence we need to do, and it's a latest minor, so it's a recommended fix as well. It's good for us to move on to that particular version. This is being more reactive. One can be proactive, however, as well. And for this particular functionality, it's called renovate. What renovate allows you to do is, if you have in GitHub as a dependency dashboard, you can open PRs to go to the latest version. Now, what that essentially means is all you're doing is you're choosing what version that you want to go, or sorry, what library you want to update to the latest version. And that means that you no longer have loads of issues. You no longer have a lot of pull requests to upgrade versions. It's all automated, and you can go to the later version that you wish to. I've raised some PRs already, and you can tell the ones that are renovate or upgrading, and because they do not have a security fix next to it. So here, for example, I could go to EJS. I click into it, and you can see that Men's making a recommendation for you to make a major jump on this particular version, so go to the later version. In terms of its age, again, this is merge confidence. Its age has a green rating, adoption has a yellow, as is its passing, and it has a high confidence as well. So you can be sure that this is a good PR for you to be able to merge. Now, of course, that leads me on to, well, what vulnerabilities am I getting myself into? As you can see here, Mend is a security check that sits within the PRs as well. So on all the PRs that you raise, if there's been a change in code or if there is a change in open source posture, what you should do is you should always be able to check and say, okay, calculated risk, I'm going into something with no vulnerabilities. And I can click into here and I can see, look, by merging this, I fixed 2 CVEs, but I'm actually not going into any new vulnerability. So I'm fixing something. The risk is eliminated at this particular point. This is really, really key, because if you're not checking those PRs, how do you know that PR isn't creating you more work, isn't taking you to actually something that is vulnerable, for example? You might have noticed in the issues here, one of them is, if I go to Momnet, this is actually a MSC, and that stands for a malicious package. A malicious package is one that could be protestware, it could be ransomware. This is part of your supply chain security, and it's an area that's growing very, very fast. You can see it on Men's analysis for this. We've said that this is protestware. Sorry, this is a suspected publisher. It's malware. And we're alerting you to that. Now, you will also notice it doesn't have a version it's fixed in. Most malicious packages won't. And that's because you need to remove that malicious package. Okay. So let's say you raise a PR to fix that vulnerability. So I've raised a PR to, if I go to files change in my package JSON, I've got rid of Momnet and I've put Faker in there because that's what Stack Overflow said for me to go to. You'll notice that, again, Mend is a check that runs on it, but it's not been successful. So maybe Faker has some sort of vulnerability or CV attached to it. Its license is good, it's license green, but I can go into here And I can see that whilst I fix one malicious package, Faker also has another malicious package associated with it. And I'm able to see where it's been found and what's actually vulnerable here as well. So again, just because you're upgrading things doesn't necessarily mean that A, that advice has been solid. You should always check it with the MEN security check. And B, always check what you're going into as well. In this case, Faker is a malicious package. You can downgrade, although it's no longer maintained. So still, that's a big value point. Are there any questions at all anyone has?
You can raise your hand. So one of the question was how would remediation work, Nick? Like, how frequently we are telling our clients about remediation.
So it's on every commit, essentially. Every commit you make, Mend will run a fresh check. It will say, okay, you have 2 less vulnerabilities, so that PR doesn't need to be there, the issue doesn't need to be there. It could then it self-manages all of that. But if there's any new vulnerabilities, it will then raise those as well.
Okay, so it will intimate via mail or via notification to change, go and change, log4j kind of problems?
Yeah, so we have proactive alerting as well on the dashboard. So it will alert you and say, hey, Anchor, you have a new vulnerability on this particular project. Here's the information, and the dashboard gets updated as well. So it's proactive alerting.
Okay, go ahead.
So this is very much kind of one area that we're looking that like a developer would perhaps be more centric into. In terms of things like onboarding, very easily onboard this. You can very quickly scale it. It's a scanning that's hosted by Ment. But perhaps a senior security persona would rather utilize the Ment dashboard, right? So what the Ment dashboard does is aggregates all these different scans, regardless whether they're different locations or not. And what it does is it gives you an output you can actually utilize at a really high level. So you can see that you have a lot more mediums, that you have highs, for example. You have a lot of findings in the code that are going up. You can get a high level view of how many scans have been done, how many policies are violated, if there's any labels. Let's say a label could be assigned to a Java team, for example, like a release label or a feature label, for example. If I just go to the dependencies themselves, really nicely, we get all the different root libraries that are present in here as well. And I can click on the root library. I can see an impact analysis, aggregated libraries, the vulnerabilities. I'm able to see the path of the dependency itself when it was last modified. And if I click into the vulnerabilities, I get a good high overview of the vulnerabilities themselves. So I can go to that particular library and I can see the information about the CVE or the WS, for example, the upgraded version. Able to go into versions as well and view the different versions. I can compare basically the different versions and get all that information out of it as well. If we go back into it, so if I go to my findings and click on the CVE, and nicely at the CVE at a really high level, you can get the proposed fixes of upgraded version, ability to change files. And if I go to details, I get information about the network vector as well. So now let's look at the code as well. So code's obviously a big part as well. You can see here the SAS scan results. So in the dashboard, so we saw it in the repo, now we're seeing it in the dashboard here. And we're seeing all the different kinds of CWEs. Now I mentioned that static or software analysis is on weaknesses, and these are just 4 of the CWEs that we are reporting on. There are many more, especially for JavaScript. I am able to go into here. I'm able to see basically like if I have a vulnerable node, weakness, and if I click into here, I can see the sync, I can see the data flow. So again, really similar, and I'm able to actually click into it and go onto the full source code in GitHub as well. And then there's some administration things you can do as well. So in terms of compliance, you can mark something as suppressed and say, okay, this is a false positive, or we have a workaround in place, which is much more common. Let's say we have a WAF that stops this from being a problem, or it's a back-end application, or it's a feature branch development, for example. You can have that. For the compliance, you can then mark things as reviewed, so you don't have to go back in and re-review it. And in terms of remediation, if you wanted to make recommendations about it, descriptions about this kind of CWE as well, all that information is built in as well as the ability to comment. That's big. So if you can comment on a particular weakness, you know someone's reviewed it, someone has made a comment against it, so they've displayed their professional opinion on something, and it leads to auditing and accountability as well. Just to build on things like compliance, especially when it comes to like regulatory considerations as well, you have the ability to export all this information via CSV. Alternatively, you can create reports, whether that's a code compliance report or a suppression report as well. You can do that, and that can be in different formats, whether that's CSV, for example, as well. You can have all of that in there. And these are kept in your dashboard under a tab called Reports. Just building on what we mentioned about libraries. So obviously the libraries are all listed here, whether they're direct or they're transitive as well. A lot of people, when they first start using them, they say, well, we're not using that library, but it's a transitive vulnerability. And here you can quickly and easily see that. And if I go to legal and compliance, I mentioned about licensing. Of course, the way we present it is going to be different. In a repo, you want actionable feedback, and you don't really want to see the scan working in the background. But here you can see the library and the severity of the particular license. In this case, MIT is a low severity license for open source. So again, at a really high level, I can just see if some have a high, some should do. Well, this one is relatively healthy, but some could be high, so they might be the GPL family, for example. But a lot in here seems to be using MIT, and you can see information about the copyright and the home directory as well. If you had any proprietary licenses, libraries as well, so we don't have any in this particular example because it's something I took off the internet. But if typically fintech companies tend to build their own in-house licenses as well, and you can mark them as proprietary. You can mark them as your own. So you give them their own license, it then recognizes it and adds it into the salted hash, and then basically you can find them and basically say, okay, again, further into compliances, these are in-house libraries. Are there any questions on the dashboard or anything anyone would like me to go back into?
If you have any question, you just raise the hand. I will allow you permission to speak. Can we integrate Mend with GitHub Enterprise?
Yes, absolutely. So whether you run GitHub or GitHub Enterprise, or if you self-host it, you can integrate Mend into there. This particular version is just the free version of GitHub. There is an app. So if you're a paid customer or you're doing a proof of concept, there's an application that is available to you, and you can utilize that. I go to my settings, you'll see the GitHub app itself, mend4github.com, and you can configure various things such as the repos that are onboarded. Just show you once it loads up. Have a nice little README section. If I go down, you can select all repositories or any select repositories as well. So it can really easily scale, especially if you're using stuff like enterprise, which means you have a lot of repos.
One more question: how different you are from your competition? Why, if somebody is already using, will they get benefit if they try Mend?
Yeah, absolutely. So there's a few key differences. One is the ability to scale at such ease. That's one less headache for you to have. The other is the accuracy. That's in there as well. And if you are a Java house, for example, if you develop using a lot of Java, you can actually have what's called reachability. Reachability is the ability for Mend to go into the application and say if you're using a certain function that is in a CVE. So if you're using a particular library in a vulnerable manner, we can actually tell you that straight from the repository itself. So that's a huge differentiator that we have in there as well. And I don't think too many of our competitors, if any, have SCA and SAST in the repo. So presented to you in PRs, for example.
There's one more question. Can we do pre-commit? Can we do pre-commit scan so I can stop committing vulnerability code?
Yeah. So the pre-commit itself would be you're scanning on a feature branch, right? So you can set. Let me show you. All I'm scanning currently is my master branch. I'm able to go into my feature branch as well, for example, and also scan here as well. So this is considered pre-commit. Alternatively, you can also scan in your IDE as well. So before you're actually committing it into your release branch or your default branch, you actually have a scan at this level and tells you what vulnerabilities that you have in here as well. That's a feature set.
Okay. There's one more question. Is there any limitation on project size, and how do you handle false positives?
So there isn't any limitation on project size. If you run I guess typically a larger project would be like the mono repos and microservices. So there isn't any limitation to it. False positives. So false positives is an interesting one. Of course, you aim to have as little false positives as possible. What we try and do is, let's say for code, which so SAST, that's more typically a false positive area. You can go into a particular weakness and you can actually say this is a false positive and you can suppress it. So that's how we handle it. With SCA, it's exactly the same. So you can go to the particular vulnerability that it has, and what you'd be able to do is to basically mute it or snooze it, if you like, and say this is a vulnerability that we know about. It doesn't affect us. Don't alert me to it. And this then pulls through into your repo as well.
Okay. There's one more question. How does automatic remediation works?
Okay, so automatic remediation, the way that it works is we've scanned your repository. We've worked out these are the libraries that you have. These are the versions of those libraries. That particular version has 5 CVEs associated. Was it Express we were using? I can't remember that particular demonstration. So here you're seeing the library that you have, the CVs that you have. And what Mend is doing is Mend is saying, okay, for all of these transitive vulnerabilities, if you, as the owner of this particular project, if you were to upgrade Express from 4.13.4 to 4.17.3, you fix all of these. And so what we do is we create a feature branch called White Source Remediate, and we basically update the package JSON because that's where they're all found, package JSON, and we upgrade that version to 4.17.3. You see the green tick, and if I go to Express, you see here, it's labeled as security fix, and we give you the PR here automatically. You can go to a later version as well. So that's the kind of the latest minor version that you can go to, but you might just want to go to this version itself, the first version that everything is fixed in. But that's in a nutshell how the automatic remediation works. Renovate kind of works similar, but it skips out this, goes to the least vulnerable version. It just says go to the latest version. So 2 different mentalities: manage the vulnerability, which is what you're seeing, and then managing the dependency, which is the renovate principle that we use.
And what is the future of SCA and open source code usage? If you can put some light on that.
So the future, where the market is definitely going, and we're seeing it with larger and larger organizations, is that you're using Renovate. So you're allowing the SCA technology, the solution itself, to check what latest version that you can go to, and then that being the cycle of managing the dependency itself. Because it's much easier to upgrade the dependencies, go to a later version, and just essentially keep it to the latest version. So what I'm certainly seeing as a trend is organizations are, if I go to my pull requests, is they are upgrade. Let's say an organization's upgrading cookie parser to the latest version. And what they're actually doing is they're automatically merging the PRs that renovate, that mend raises, and saying if there's a confidence of high or very high, just automatically merge it. More often than not, it's a minor change as well. It's a minor upgrade, which is a non-breaking upgrade. And so they're just saying automatically merge it. So it's almost like you're now on autopilot. The solution itself is taking over and you are like a zero touch in essence. That for sure is a trend that people are going to.
Thanks, Nick. Any more questions? Can we create a policy check based on severity of vulnerability and risk?
Yeah, absolutely. So in your dashboard, one can create a policy if I just go to our policies, you can create a policy for licensing, for example, let's say, or severity of the vulnerability. That's also possible. I can add a policy here for CVSS score, for example, that's one in there. And as you saw, so this policy here is what's taking effect in my repo. So basically, one of the checks here is license check as well. So if anything has a bad license, there's two things. One is you're going to be alerted to it via the mend license check. The other is if there are any violations, you're going to get a issue raised as well. So that's kind of two things that the policy does. One is it raises issues, and one is it checks on every PR and every commit that you're not introducing a bad license into your branch. I hope that answers your question.
I think so. One last question I am getting on my personal window is, how do we try mend on our source code, and what is the process for that?
In terms of a proof of
Yes.
concept, certainly.
Yes.
Okay.
Yes.
So I guess in terms of like either reaching out to yourself or to Meteonic or to Mend, the process is if you have a project of such sorts, what you can do is you can have a proof of concept with us. What that entails is integrating into your environment. So whether that's scanning locally, whether that's the repo integration that I've showed you today, or alternatively, if you have let's say a Jenkins or another CI/CD solution, we integrate into there. And based on the criteria for a successful proof of concept, what we can then do is ensure that you are hitting those value points. So you are getting good and accurate results. You are finding the value that you want in terms of licensing, reporting, for example. So over a period of about a week, 2 weeks, we can do a proof of concept, get you embedded. It's nice and easy. And then you have access to a solution engineer such as myself or a colleague to ask any questions of as well.
Thanks, Nick. Can any more question? Anybody wants to have a comment? My team will definitely reach out to you for your interest in proof of concept, and if you want dedicated demo, we can definitely do that. So if there are no more questions, Akash, you can stop recording. I thanks Nick and Noah for facilitating such a nice session. I hope you guys have learned something and you will implement some of these things in your projects to make sure